Good morning and good afternoon, everyone. Welcome to our webinar in which we will present you 5 mistakes to avoid in the industry. My name is Jean-Marie Dubois. I am a Business Development Manager at Sofraser.
And I'm Philippe Berg, and I'm Sales and Application Manager at Sofraser too. Sofraser was founded in 1972 and we manufacture process viscometers for more than 40 years. Our instruments are based on the technology of vibration resonance frequency, which has been invented and patented here at Sofraser in 1981.
Sofraser is a pioneer in inline viscosity measurements, and thousands of instruments are installed worldwide in all industrial fields like oil and gas, food and beverage, polymers, adhesives, and so on. Our sensors are compatible with any kind of fluid or paint and are long-lasting with a minimal maintenance, ensuring decades of intensive use in the harshest environments.
Viscosity is the physical property that describes how a fluid is flowing under a constraint, like gravity, for example. When viscosity is low, the fluid flowing very rapidly. When the viscosity is large, it takes more time for them to flow. Viscosity is important in the process industry and its numerous operation units for several different reasons. The first one is that for some products, viscosity is the property that describes the quality of the product by itself. For example, viscosity is the key specification of lubricating oils. Some other fluids, like fuel oils, from light to heavy, paints, inks, glues, etc., have also viscosity in their specifications. For other products, viscosity is an indirect way to measure another important property. For example, viscosity of a polymer solution or a mixture is closely related to the molecular weight of the polymer chains. Viscosity can be correlated to other properties like concentration and dry extract, for example. And finally, viscosity can impact how efficiently a product is handled by an operation unit. For example, the size of the drops is closely related to the viscosity of the liquid that is sprayed, and this has an impact, for example, on the efficiency of the combustion of fuels or the quality of painted surfaces.
First discussion will be about the lack of instrumentation. As you know, a typical way to control your manufacturing process is to take a sample and send it to the laboratory for a complete analysis. This step, which requires human action, is not always easy. It can be dangerous due to the product, which can be hazardous, or because of the pressure and temperature conditions that furthermore complicate the sampling itself. But overall, it creates discontinuities in monitoring of the whole process. Indeed, the time to get the results from the laboratory, deviation can occur without being aware of them, and this late detection can create huge issues in quality of the final product. Integrating inline instrumentation, like a process viscometer that provides instantaneous measurements, is the right solution to minimize the sampling problems. It grants continuous monitoring with no downtime of the information. Therefore, it allows you to react immediately to correct any deviation detected and guarantees a perfect control of your process to enhance your manufacturing in real time and in safe situations. Inline viscosity monitoring will bring you one step ahead to react before things get worse.
Polymerization is a well-known activity in the chemical and petrochemical industries. The objective is to manufacture the polymers that are large molecule weight molecules, thanks to the monomers that are very low molecule weight raw ingredients. Challenge for the operation team is to manufacture the right grade of polymer in the best time and using the less raw materials and energy. The kinetics of polymerization reaction is controlled mainly by temperature and catalyst and is sometimes an exothermic reaction. A too slow polymerization reaction means longer batch duration and lower production capacity. A too fast reaction means an increasing risk of reaction overshoot, and this is especially true when the reaction is exothermic. Besides the risk of manufacturing a batch of polymer that doesn't meet the specification, there is the risk of viscosity overshoot and hardening of the content of the reactor. This is a major accident. Indeed, it combines the loss of the batch and at least a long period of unavailability of the facility combined with equipment damages. Implementing and using a process viscometer provides an instantaneous and continuous information about the status inside of the reactor as well as the kinetics. This is a valuable aid for the manufacturing team.
The next point we will focus on is the overconsuming of key ingredients. Many companies use ingredients in excess in order to keep a high quality standard of end product. This is mainly frequently done because of the lack of precise monitoring of their process, and it brings to higher consumption of raw material, which can greatly impact the cost efficiency of the whole process. This is especially true when expensive ingredients are involved, and therefore this higher cost drastically decreases the global margin of the end product final use. Fine-tuning of the ingredient ratio during production can be achieved thanks to an instrument especially prepared to match the technical requirements. It must of course comply with the process condition, but it shall also be correctly adjusted to the product to measure in order to provide the most consistent information possible. That is why all our viscometers at Sofraser are calibrated in accordance to the viscosity range expected by the end user. Optimize its response when in use during the manufacturing. Precise measurements with the proper instrument allow accurate control of the process to reach the perfect recipe at the best price.
We already discussed the topic about process instrument versus sampling and laboratory measurement as a help for process monitoring and control. Not all process instruments and viscometers have the same level of performances. Precision is a key specification for a process viscometer. Indeed, process instruments are directly installed on the industrial facility, are operated in harsh conditions compared to the laboratory instruments. Precision refers to the availability to measure and deliver the same information when the conditions are the same. For an instrument that operates 24 hours a day, 20 days a week, it is difficult to remain precise throughout its entire lifespan, with spans from years and even decades. A viscometer that has not a warranted precision during its lifetime will deliver unreliable information, especially when there is a shift or drift in time. Progressively, the quality of the final product will leave the expected specifications and end user will face a loss of quality. Sensitivity is also very important. Sensitivity quantifies the smallest viscosity difference that the instrument is able to detect. Some processes and products have a very narrow range of specification and they require a process viscometer with the best sensitivity in order to detect the differences. Sofraser viscometers, thanks to the vibrating at resonance frequency working principle, offer the best sensitivity for process applications.
The last point we will discuss is about robustness of the equipment. Depending on the technology on which is based the instrument, various issues can occur. For instance, when parts in movement are involved within the sensor, a drift in time is very frequent. It creates inconsistency in the measurements and therefore unreliable information, compromising the control of the process. Moreover, this kind of sensor also needs to be regularly calibrated in order to keep consistent measurement. During that period of time, the process is not anymore monitored and that can lead to traceability lost. Instruments with wear parts also present a high risk to break, causing long time and costly maintenance, or even worse, production shutdown. Sofraser analyzers are measuring viscosity thanks to a vibrating rod immersed in a fluid that is held at its resonance frequency. This means that there is no moving parts, as this is just a vibration, and therefore no wear parts, so no drift in time. The design of the sensors allows them to work in harsh conditions up to 300 degrees and 1000 bars. They are proven to be very robust and long-lasting, as many units are still working on field after more than 3 decades installed on process and working 24/7.
Purchasing and implementing a process viscometer like a Sofraser is an investment that is roughly in the 10 to 30,000 USD according to the detailed technical configuration and choice of options. Most of the end users notice a fast return on investment after 6 months in average. Process viscometer provides a continuous and instantaneous monitoring of the viscosity that allows the end user to reach the best efficiency thanks to better process control, reduced loss of end product that is out of specification, saving of raw ingredients and energy, increased productivity, less stop of production thanks to the optimization of the manufacturing cycle, long-lasting equipment, trouble-free during years and even decades.
Viscosity is a fundamental parameter which can be critical to monitor for many industries and numerous applications. It directly influences the quality of the product and the efficiency and profitability of your process. Preventing those mistakes to happen will grant you with a better product quality, reduce the waste of materials, and improve your production cost and efficiency. Inline viscometers will give you useful and reliable information about your process in real time and continuously. Thanks to this robust equipment, you will be able to closely control your production. So now you know everything about how inline viscosity measurement can help you to save money every day.